Hello and welcome to this Promathematica for Competitive Exams channel. My name is Gracie and I've been teaching mathematics and Java since the early 2010s. We're going to start the discussion about competitive exams a little differently than you may be expecting. This module elaborates the problems and solutions for aptitude test and its comprehensive demonstration through Java programming. Why would I want to use Java? Well, here's a peek ahead at the answer. Because we'll be able to develop easily. A competitive examination is an examination where candidates are ranked according to their grades and/or percentile, and then top rankers are selected. Competitive examinations are considered an egalitarian way to select worthy applicants without risking influence peddling, bias, or other concerns. Early exposure to learning and competition builds confidence and sharpens skills, which raise your level from other students on the same platform. Competitive exams also help out in choosing a career as students start identifying their areas of interest while getting a deeper knowledge of subjects. Top business schools based in North America, Europe, Asia, and Australia conduct this exam. Several leading corporations also conduct such tests for assessing potential candidates' quantitative reasoning skills. I am going to cover another important topic. It is based on trains, distance, time, and velocity. Train problems form an integral part of the time and speed questions. Similar to the concept of speed, distance, and time, train problems are specifically based on evaluating the speed, distance covered, and time is taken by a train under different conditions. There are specific formulas which are to be used to find answers to the train-based questions, and candidates must memorize them in order to crack the answer for problems on trains. Two trains of equal length are moving in same direction on parallel tracks at speed of 92 km per hour and 72 km per hour respectively. The faster train crosses the slower train in 18 seconds. Find the length of each train. Here is an answer with explanation. Let the length of each train is x. Distance covered equals 2 times x, sum of the length of trains. Relative speed of faster train equals 92 minus 72 is equal to 20 km per hour. Relative speed in meter per second equals 50/9 meter per second. Relative speed of faster train equals total distance covered by the time taken to cross the slower train. Therefore, the length of each train means x equals 50 meters. A train of length 150 meters running at 100 km per hour. It crosses another train, which is moving in opposite direction at 80 km per hour in 8 seconds. Find the length of the other train. Here is an answer with explanation. Relative speed equals 100 plus 80 is equal to 180 km per hour. Relative speed equals 50 meters per second. Let the length of the other train is equals x meters. Now relative speed equals total distance covered by time. x equals 400 minus 150, x equals 250 meters. Two trains of equal length 200 meters are moving in opposite direction on parallel tracks. The trains cross each other in 10 seconds. If one train is moving twice as fast as the other train, find the speed of faster train. Here is an answer with explanation. Let the speed of the slower train equals x meters per second. Then, the speed of the faster train will be equals twice x meters per second. Relative speed equals x plus 2 times x equals 3 times x meters per second. Relative speed is also equals sum of the train's length by time taken to cross each other. After solving the equations, the x becomes 48 kilometers per hour. Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. Programmers write once, run anywhere, meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. The JDK is a development environment for building applications using the Java programming language. The JDK 12.0.2 Windows x64 bin exe includes tools useful for developing and testing programs written in the Java and running on the Java platform. In addition, the Spring Tool Suite, STS, provides the best Eclipse-powered development environment for building Spring-powered enterprise applications. STS supplies tools for all of the latest enterprise Java and Spring, and comes on top of the latest Eclipse releases. STS supports application targeting to local, virtual, and cloud-based servers. It is freely available for development, and internal business operations use with no time limits. Here is the problem statement. I am going to define a new method for determining the time for earlier solved problem 1. Let the length of each train is x. Distance covered equals 2 times x, sum of the length of trains. Next, relative speed of faster train equals 92 minus 72 is equal to 20 km/h. Relative speed in m/s equals 50/9 m/s. Next, relative speed equals 92/72 multiplied by 5 divided by 18. Next, the train's length equals 900 by 18. The last step is to return the train's length value. Here I am printing the time by calling velocity time distance method. Here is the problem statement. I am going to define a new method for determining the time for earlier solved problem 2. Define train 1 speed, train 2 speed and train 1 length member variables and initialize them. Next, relative speed equals train 1 speed plus train 2 speed multiplied by 5 by 18. Let the length of the other train is equals x meters. Now, relative speed equals total distance covered by time. Equals 150 plus x by 8 is equal to 50. Next, the train 2 length equals 400 train 1 length. The last step is to return the train 2 length value. Here I am printing the time by calling velocity time distance method. Here is the problem statement. I am going to define a new method for determining the time for earlier solved problem 3. Let the speed of the slower train equals x meters per second. Then, the speed of the faster train will be equals twice x meter per second. Relative speed becomes equals x plus 2x equals 3 times x meter per second. Relative speed is also equals sum of the length of trains by time taken to cross each other equals 400 by 10 is equal to 40. X equals 40 by 3 meter per second. X in kilometers per hour equals 720 by 15 is equal to 48. Next, the faster train speed becomes twice of the slower train's velocity. The last step is to return the faster train speed. Here I am printing the time by calling velocity time distance method. Hope you liked this video. In order to see new videos, don't forget to subscribe to Promathematica channel.